All right, today we're going to go through a step-by-step tutorial on using code blocks in Tinkercad. So the first step is to log into your Tinkercad account, and over on the left-hand side you'll notice there's a code blocks option. And to start a new code block, I just click create a new code block and then click new design. We have a work surface here that will show our blocks of code, and on the far right we have our familiar work plane that will show us what our design looks like. So I'm going to drag a box out, much like I did in regular Tinkercad. It doesn't show up here yet because I need to click run to run the program, and now the block appears. So we can see that it's centered in the X direction and the Y direction and also in the Z direction. So you'll see that the half of the cube is below the work plane. And if I click this to expand the arrow, I can see that the cube dimensions are 20 by 20 by 20, just like they are in regular Tinkercad. Those are the default dimensions. So I can change those dimensions if I want the block to be wider in the X direction. I can change that dimension and then click play, and you can see that again it stays centered, but it's now 50 millimeters long, and I could make it 10 millimeters tall in height and so forth. And in the Y direction, let's say I'll make that 10 millimeters as well. Maybe I'll make the height 5 millimeters. Okay. What I'd like to do in this exercise is to create a radiating pattern of these rectangular rays and have an open circle in the middle. So let's see, how can I do that? The first thing I want to do is move the rectangle to the right. I know it's 50 millimeters long, so if I move it to 25, then it'll be, the edge will be aligned to the origin point. In addition to adding shapes, I have modifiers I can use and controls, and I can do some math, and I even have markup, which is handy once your program starts getting more complicated. So let's see, I want to move in the X direction 25. So if I play my program, okay, so it adds that and moves it out. I'm going to change this, the length to 5 and replay. So I have a thinner array here because I know I'm going to duplicate it and rotate it around, right? So the other option, a couple other options with running the program, you notice there's speed, so I can do it slowly or medium speed or quickly. You can see how fast, just almost instantaneous, but doesn't matter much now because we have a very short program, but once we start getting more steps, then you might want to speed up your result. The other thing you can do is I'll reset back to 0, and you can step through step by step. So if I click on step, it might be hard to see in the video, but the first line of code is being executed and it's highlighted in black, and you can see the the shape was added. And then if I click next step, then the next step is highlighted, and that's where the ray is moved over. So I'll reset. And before I get much further, I'm going to go ahead and add a comment up here. And I'm going to say, create each array. Okay. And I'll put a comment here, and I'll say, move each array, so that I know what's going on. All right, so I've got one ray, and I would like to create others. So repeat, that looks like that could be handy. So if I drag this out, and so it surrounds my existing code. If I repeat one time, let's say I'd like to have 4 rays to start with to keep things simple. Eventually what I'd like to do, and one of the real strengths of going through this whole process of writing a program instead of creating an individual model from scratch, is that I'd like a parameter up here that I can set and tell it, the program, do I want 3 rays, 4 rays, 10 rays, 25 rays, and all I have to do is change that one parameter, run the program, and it will very quickly create my model. So that's where we're heading, but for now, let's say 4 times. I just want to see what that looks like. Oops, okay, so what it did is I created 4 rays, but of course the same function is being applied to all of them. So what I need to do is, after each ray is created, I need to rotate it around the origin point. If I have 4 rays, then it'll be rotated 90 degrees, then 180, and then so forth, another 90 degrees. So I'm going to need some variables now. First of all, I'm going to create a variable for the number of rays. So I'm going to drag this create variable, and I'm going to rename it number of rays. Okay. And then if I scroll down on the left, you can see I now have a variable number of rays over here. So I can click and drag that, and I'm going to drop it right where that 4 is. So if I change that to 2, this loop will be repeated twice, and it will create 2 of those blocks. Again, it went fast. If I do it more slowly, so it creates 1, moves it over, creates the other one, and moves it over, right? So there's 2 there. So now again, I need to know how many degrees to rotate this around the origin point. And that degree of rotation is going to change based on the number of rays. So I've got to do some math here. I need to create another variable. And this one I'll call angle of rotation. And the angle of rotation will be 360 degrees divided by the number of rays, right? So if I have 2 rays, 360 divided by 2 would be 180. So that would create the second one rotated 180. Okay, so I need to insert some math instead of where that 0 is. So let's see here. All right, this is the one I'm looking for. So I can type in here 360 divided by the number of rays. Okay. So angle, that will give me my angle of rotation. All right. So now, if I go back up to my modify options, one of them is rotate. So if I put that after the move, so a ray is created, and then it's moved over to the right. And now I want to rotate around the z-axis, right, the up and down axis. Just imagine a line going straight up and down right through the edge of this ray here. And I don't want to rotate it by 90 degrees. I want to rotate it by the angle of rotation. Okay, and around the pivot point. So right now, the pivot point is the center of the object, this ray that I created. So I don't want to rotate around there. I want to rotate around the left-hand edge there, the 0 axis, or the origin point. So I'm going to drag this out, and oops, let's see if I can. Okay, see what I'm trying to do is, you'll notice as I'm moving these variables and these math operators out above these slots that I could put it in, once I get it sort of close, it gets highlighted. So now I can let go and it'll drop it right in there. So the origin point is x0, y0, z0. Okay, so that's good. So what's going to happen? This is number of rays. All right, well, let's run it and see. Okay, so that's not exactly what I wanted, kind of, right? But I want the first one to stay there. Rotate around the angle of rotation, because the angle of rotation is this calculated number. That's 180 degrees. But I need to start with 0. So I'm going to create another variable. And this one I'm going to call rotation counter. And that I do want to start at 0. And instead of angle of rotation, I'll drag that out, put it in the trash. I want rotation counter. Drop that in there. But that's going to be 0 all the time. So somehow I need to increment that. So what I can do is drag this change function out here. And I'm going to change the rotation counter by the angle of rotation. Right? So the first time this loop runs, the angle will be 0, so that'll create one ray and leave it there. Then it'll go through, then it'll increase the rotation counter from 0 to 180, and that's calculated up here by the angle of rotation variable. So the second time the program runs through the loop, a ray will be created, it'll be moved out, but then it'll be rotated 180 degrees in theory. So let's see what happens. There's our first one, second one, whoop, okay. So that is what I wanted to happen. So again, the idea is that the only thing I should have to change in this program is the number of rays at the top. So let's say I change it to 3. See what happens. There's 1, 2, 3. Hey, look at that. And you can see that they're all equidistant from one another. And if I change it to 13 and run through the program, so you can see this is where it's running slow. So I'm going to pause it and reset. And instead of waiting it for the program to run through 13 times, I'm going to knock the speed all the way up, and now I'll play. There we are. Okay. So that's pretty good. But what I'd like to do is have a hollow circle in the middle. So instead of moving 25, what if I move it 30 and run? Okay, so there's a hollow circle in the middle. And let me try with just a lower number of rays to make sure it still works. Whoops. Okay, so when I had a lot of them, there was enough overlap to connect those pieces, but they're not connecting now. So what I should do is add something here in the middle to connect them. And going back up to my shapes, I have a tube, and the radius is 10, wall thickness is 2, sides is 24. So you remember in Tinkercad, the number of sides determined how rough or smooth the shape is, right? If you think of the cylinder with a few sides, so for instance, I'll put 5 sides here and just run the program and see what happens. So you see I end up with a pentagon, right? But what I'd like is a nice smooth surface there. So I'm just going to go ahead and type 999 and then run. And so now I get a nice smooth surface there. Radius of 10 is probably fine. But so I'm going to go back. So if 25 is half of 50. So if I move it out 25, each of these is going to be exactly at the origin. And if I add another 10, then it should be the same radius as this tube. So I'm going to change that to 35 and then run the program. Okay. So just checking it out, make sure everything is hunky-dory. Well, top. So if I zoom in, I can see that indeed it's matching precisely, but the problem is there are these little gaps here between each ray and that circle. So I do want to push that in a little more. So what I can do maybe is let's try making the radius of this tube 15. Whoops, way too much. I just need a little bit, so I don't know, let's try 12. Okay, I don't want the rays poking into the middle. I just want them fitting in there. So if I do top and I make sure I'm on orthographic view and then I zoom in, I'm not seeing any gaps there. Okay. So there are a couple other things I still want to do. You can see that half of the shape is below the surface. So if I go back up to where the ray is created, I move each ray over 35, but I can also move them up. So I know that the height is 5, so half of the ray is below, so I can type in 2.5 here, and then if I run this, okay, we can see that it's flat on the surface. I can put a move function down here for the ring. The ring is 10 high, which I don't want. I want it to be the same as the ray height, so I'll change that to 5. And then I can run, but you can see half of it is below, so I can move it up 2.5 millimeters, run. All right, so it's now even there. Okay, and this is good too, because now I can see how far in each ray goes. There's sort of a ghost shape here that's showing me. That's perfect, right? It's kind of embedded into the ring. But the reason it's displaying this way is because these shapes are not combined. They're still all separate shapes. You know, in Tinkercad, we need to group shapes, right, to turn multiple shapes into a single model. So down at the bottom, what you can do is, where is it? Not create new object, create group right here. So I'll group them together. And what I'll do also is I will change the colors of the ray and of the ring to yellow, and now run. Okay, and so then I have this object, which I can come up here and I can change this to 25 and run. And I can change it to 2 and run, and 1 and run. So any number that I type in here should work and create this radiating shape. So the last step is really important. I mean, it's all fine and dandy now, right? We understand everything that's in here, but if we come back in 2 days, we'll forget everything that's going on. So you want to comment your program. Input the number of rays desired. Okay, I'll put that up here. And calculate the angle between rays. All right. And this, set the rotation counter to 0. All right. And this creates, moves, and rotates the rays. And we already said, okay, so this part creates the ray, this moves each ray. To the right and up. This next part rotates each ray around the origin point. And this next line increases the rotation counter, whoops, by the angle of rotation. Scroll down, let's see, move this down a little bit, move this down here. Give myself some space. Okay, this creates the center ring and moves it up. Or I could say just that line creates the center ring, and the next line moves the center ring up. And then finally groups all shapes into a single model. All right. Don't think I have any typos there. So you can see how, I mean, obviously you could create any one of these individually in Tinkercad using the primitive shapes. And it took some time to write the program, but now that it's written, it's super easy for me to just change that one variable, and I can very quickly create, almost an infinite number of models from that. And you're not limited to that one variable. I mean, if I wanted to be able to input the length of the ray, I could create another variable called ray length, right, up at the top, and then, or width, I should say, ray width. And then instead of having the number 50 here, I would drag over that new variable, ray width, and drop that in there so that up at the top I could input the number of rays, but also how long I want each ray to be. So why don't we just go ahead and do that? We'll create another variable. Let's see, give myself some room to put that in here. And I'm going to put a comment right on top of it right away. Input the width of each ray. Okay, so I'll call this rename variable ray width. All right. So now, you may have noticed if you move these pieces too close, they kind of stick together. But then you can take them apart again. It's almost like they're magnets and kind of plopping them together. In this case, I would actually stick those two together because these are both inputs. Just for me, visually, it's easier to see. So ray width, we have one more thing to do here because I've got that number there, and I'm going to put this in here instead. So we started with 50, so I'm going to enter that, and it recreates that. So now if I want 25 instead, and I run the program, up. Okay, so because I moved the rays over half of their width plus 10, I need to do some more math. So down here where I had move, I'm going to drop that in, and I'm going to say ray width divided by 2, right? Half. All right, so I'm moving it over half the length. Let's see what that looks like. Okay. That's fine. Over and up. But I need to move it a further 10 out. So I'll put another move here and move it 10 more. Okay, let's see. Move, move. Okay. All right, let's put this on full blast. And ding, okay. All right. So that should work for any width. So let's try something else. Let's try, I don't know, no, 50, ray width. Let's try 10. And let's try 4 rays. Hey, look at that. Let's try 2 rays and 100. Wow, look at that. Pretty cool. So we now can determine with one variable the number of rays, and also with the second variable the length, or I keep saying length, the width of each ray. Obviously, there are any of these set numbers that we entered, we could turn into variables. So we could, the height of the whole thing could be a variable. The length, or the sort of thickness of each ray, could be a variable. The diameter of the inner circle could be a variable. As long as you keep in mind that whenever you turn one of these numbers into a variable, if that number is dependent upon anywhere else, that you might have to do a little bit of extra math using some of the functions on the side. So that's how you use Codeblocks. And up at the top, I'll give it a name, Ray Generator. Okay. And if I click on the Tinkercad logo to go back to my dashboard, you can see that it's now one of my code generators, and whenever I want to use it, I just click Tinker this, and I can come in and go to the top, change my 2 variables to whatever I want, run the program, and I have my new model. And of course, I can export as an STL. I also have other options. If I export as STL, I can see my shape. If I export as shape, right? Remember, this is when we created our own shape. So I could say 5 ray star, right? And I can say save shapes. Now, if I go into Tinkercad and designs, and I start a new design, and under basic shapes, I choose my creations, there's the 5-ray star that I just created. So I can drag that out, and there you go. Now I don't have, all I can do is change the length, the width, and the height here. I don't have the options to generate the shape within this work plane or within this part of the program. But you can always come back here, rerun your program and export your shape. You can also share your code block. And if you use that option, you can take a screenshot, which is a nice clean image that you can post and share with others. But you can also create an animated GIF. And so if I look at that, it actually is an animated GIF that you can share with folks that show the steps of your creation being made. So that's pretty cool. And lastly, if I can go back out to Tinkercad dashboard, and I hover over the shape, click on the gear icon and properties, I can make this public so that others can see it. Save changes.